a huge mountain range stretching 1,600 kilometers, where more than 20,000 Chinese workers are busy from morning till night deep underground. They operate huge shield machines, accompanied by the roar of machinery, and are digging a huge underground hole. And what they are building is the most difficult road tunnel in Asia. But before the project started, some Western media believed that the Chinese engineering team could not complete this tunnel project at all. After all, this mountain range with extremely complex geology is so complex that even the top engineering teams in the United States dare not try it. So the question is, why does China want to dig a tunnel under such a group of mountains that is extremely expensive and technically difficult? And how is this project now? If you like our video content, please click to subscribe to my YouTube channel so that you can receive all our latest video content. Now, let's get into today's topic. This is China's Qinling mountain range, lying like a giant dragon in the middle of the city, splitting it in two. To the north is the open and flat Guangzhou Plain, and to the south is the undulating Hanzhong Basin. For decades, this mountain has always been a transportation problem. The Chinese have no choice but to take an old road that winds around the mountainside. Although the distance between the two places is only 80 kilometers, it takes them several hours to travel back and forth. As China's tourism industry develops better and better, people from the north and south are traveling more and more frequently. During the peak tourism season, the city received more than 300 million tourists and an average of tens of thousands of vehicles squeezed into the winding mountain road every day. However, this road can only handle 20,000 vehicles at most, and overload operation has long become a norm. Against this background, the local government began to plan to build a modern super highway tunnel deep in the Qinling Mountains to truly connect the northern and southern cities. As early as 2001, China invested $560 million to start the construction of the highway tunnel and planned to complete it within 6 years. According to the plan, the tunnel is 18 kilometers long with a double-hole 4-lane and one-way 2-lane design, and the driving speed can reach 80 kilometers per hour, even if more than 30,000 vehicles pass through every day. The entire project is built according to the first-level safety standard and has a service life of up to 100 years. However, there's almost no precedent in Asia to build a highway tunnel in a place with such a complex geological structure in the Qinling Mountains. In order to overcome the technical difficulties, China also sent a team of engineers to the United States to study and exchange. However, during the communication process, the American engineers were all stunned after listening to the content of the project. If it were in the United States, such a complex tunnel project would require at least $1.7 billion and would take at least 10 years to build. But such a long construction period has completely changed China's original plan to build it in 6 years. But faced with this series of almost hell-level engineering challenges, even experienced Chinese engineers were stumped for a while. Based on the technical level at the time, there was no ready-made way to solve these problems, and the project advancement was almost deadlocked. But they did not give up. On the contrary, Chinese engineers began to convene experts in the field of roads and tunnels from all over the country on a large scale, and even invited top foreign engineering consultants to participate in the discussion. Such brainstorming lasted for several months, allowing the project to make new progress. In March 2001, China sent 12,000 workers to implement the Qinling Highway Tunnel project. But soon, Chinese engineers found many problems when exploring the terrain. In most engineering specifications, tunnel construction sites should try to avoid complex geological areas, such as faults, rocks, and areas with abundant groundwater, which are all high-risk areas. But in the Qinling area, all these dangerous factors are gathered together. The groundwater level fluctuates violently, and in severe cases, thousands of cubic meters of water can gush out every hour, and it only takes a few minutes to engulf the entire construction site. In order to solve this problem, China first invited a number of well-known tunnel experts from home and abroad. They repeatedly surveyed the geological site, conducted simulation tests with a large number of field samples, and finally selected several feasible designs from a series of failed plans. In terms of groundwater control, the Chinese construction team used technical means such as numerical simulation and artificial neural networks to continuously predict and control the risk of water inrush and minimize the impact of sudden water inrush on construction. After solving the hazards caused by groundwater, rock bursts are also a huge problem faced during the construction process. Because the Qinling Mountains are the junction of North China and South China, when the tunnel passes through it, the surrounding ground stress is 3 to 4 times higher than the initial stress. So the power of the rock burst is also sharply increased. And once it hits the machinery and workers, it may cause serious injuries. Even if there is no injury, the heaviest stones that can reach several tons will cause difficulties in cleaning. According to statistics, there were 721 rock bursts during the excavation of the tunnel, accounting for 77% of the length. In order to protect the lives of construction workers, Chinese engineers had to wear bulletproof vests and helmets. In some high-risk areas, they even built bridge-shaped steel frame structures to reinforce the rock walls to prevent casualties caused by instantaneous rock collapse. At the same time, in order to resist flying rocks, they also set up temporary protective nets on site. These protective nets are woven from nylon and steel wire, which can immediately block the high-speed debris ejected during rock bursts and protect on-site equipment and personnel. In addition, Chinese scientists have independently developed a new type of anchoring material, negative Poisson's ratio anchor rod. This material has high strength, sufficient toughness, and strong impact resistance, and is regarded as the black technology of rock burst control. Once the rock mass is found to be unstable, it can quickly play the role of compensatory support, reduce the degree of damage in a very short time, and win critical seconds for rescue. As we mentioned before, the hardness of the rocks in Qinling Mountains is almost nightmare level, especially granite, which can reach a hardness of 316 MPa, which is the ceiling level in the geological circle. Moreover, up to 96% of these rocks are quartz, a mineral that is extremely difficult to handle. Traditional excavation equipment is almost turned into scrap metal in front of hard rocks, and the efficiency is directly cut by more than 50%. Moreover, on average, a large number of tools are scrapped for every 100 meters of advance. The cost of a tool is as high as $5,000 and even close to $8,000 when it is expensive. But we all know that China is known as the infrastructure maniac. They can even develop some of the most powerful equipment in human history to solve problems. When building the tunnel, Chinese scientists developed a super heavy equipment specifically for granite. This equipment is also called a full-section hard rock tunnel boring machine and is one of the most important equipment in modern tunnel construction. In the past, TBMs used a simple roller cutter to break rocks. Once they encountered high-hardness rocks, the cutting effect was poor, the advancement speed was slow, and the main bearings were particularly prone to wear, resulting in frequent maintenance and extremely low efficiency. The special feature of the Longyan developed by China is that it adopts the design concept of double knives in one. On one side is a traditional roller cutter, and on the other side is a high-pressure hydraulic jet. The two rock-breaking methods work together to reduce the advancement pressure by 30% to 40%, and also reduce the wear of the cutter by a quarter. When the technical difficulties in construction were solved one by one, another more difficult problem followed air. Because in an 18-kilometer-long tunnel, if the ventilation system is not in place, car exhaust will accumulate in the closed space like poisonous fog. Carbon monoxide, nitrogen oxides, high concentrations of PM particles, etc. As long as there is no ventilation for 1 or 2 hours, the entire passage will become an invisible gas chamber. Therefore, how to keep this super tunnel full of fresh air has become a technical challenge that all engineers must face. In order to solve this problem, the Chinese engineering team began several months of calculations, simulations, and experiments. They built a complete airflow model, restored the tunnel structure one-to-one in the laboratory, and studied the propagation path of exhaust gas, wind flow rate, etc. In the end, an unprecedented plan was proposed by Chinese engineers, that is, building wells in the air. Finally, in 2005, China sent another 8,000 workers to complete this building wells in the air project. Engineers decided to dig 3 giant ventilation shafts vertically from the mountain to the top of the Qinling tunnel. The deepest of them reached 661 meters, which is higher than the Shanghai Tower in China. Above these shafts, Chinese engineers installed air exchange equipment that operates around the clock. These devices work day and night to extract exhaust gas and press fresh air in to keep the air flowing throughout the tunnel. No matter how many vehicles pass through, the air breathed by the driver is always the same as the outside world. Finally, after solving numerous problems, the Qinling Highway Tunnel was officially put into use in January 2007. The entire project took only 6 years, which directly broke the Western perception of China's infrastructure technology. With the official commissioning of the tunnel, the time to cross the Qinling Mountains, a natural barrier between the north and the south, was shortened from more than 2 hours to less than 30 minutes, and travel efficiency increased by more than 90%. This once insurmountable geographical barrier has now become an important channel connecting the north and the south. For this reason, this Qinling Highway Tunnel is hailed by many as Asia's #1 tunnel. But the challenges of Chinese engineering in tunnels have also developed from underground to under the sea. In 2009, Chinese engineers built one of the world's longest road undersea tunnels, the Hong Kong-Zhuhai-Macau Bridge Undersea Tunnel. The entire tunnel is 5,664 meters long and is composed of 33 giant immersed tubes and a final joint section. The maximum installation water depth is over 40 meters. The amount of steel plates used in the main beam construction of this section of the tunnel alone is equivalent to 60 Eiffel Towers. Among these 33 immersed tubes, the volume of each section is even larger than that of an aircraft carrier. According to the design plan of the undersea tunnel, the service life of this tunnel is 120 years, with a 9-degree earthquake resistance, can withstand a 16-level typhoon, and can even withstand the impact of a 300,000-ton ship. Over the past 10 years, we can see that China has made amazing achievements in infrastructure development, even ahead of the United States. At the same time, they have also begun to help other countries build large projects. For example, in Europe and Africa, some railway and bridge projects are also built by Chinese companies. This also proves the hard power of Made in China to the world. To not miss out on our future projects and news updates, please make sure you subscribe to our channel and turn on notifications. We will continue to provide you with more exciting and interesting content.